right, so if you notice your radical functions, and I kind of get to split my paper up because I printed them separately. Big notice, these are inverses, guys. If you notice, this is an inverse right here of this graph. This is, or actually, I'm so sorry, it's the inverse of here. If we took this positive branch and tilted it on its side, it'd be right here. Please notice that this is a little graphic to show you when a root is even, and look, when it's an odd, it's just going to be a sideways whole thing there. So everything that we've learned about inverses certainly is going to carry over. Like, rules don't change on inverses. All right, so same rules apply, guys. You can have a positive function and you can have a negative function. If I have a negative leading coefficient over here, then it is going to be down on the right. If I have a positive coefficient, it's going to be up here on the right. Real quick, here we go. What we're going to do is we're going to plug in values that we're going to take the fourth root of. So that's going to just be some crazy numbers here, guys. So if I put in 1 times 5, of course, is not going to be a perfect fourth root. So this is just going to be 2 square root of 5. Now, if I put in, I just did 2 to the 4th power in my head. So if I did 2, of course, this would be 2 root 2 times 5 is 10. If I do a 3 here, this would be, oh, and by the way, these are all fourth roots. This would be 2 fourth root of 15. 2 fourth root of 15. So if you notice, guys, these numbers are increasing by a minuscule amount. So if I plot the x value of 1 and root 2, fourth root 5 may be right here. The fourth root of root 10 is going to be just barely above it. These become almost impossible to graph. That's why drawing a sketch is going to be fine, guys. Everything else is just going to be off the graph at that point. So that is going to be the graph of this with an even root. Just remember, when you take an odd root, remember the domain is negative to positive infinity, and it's going to look like this curve. Let's make this simpler. Let's just go ahead and erase this, guys. We are just going to take the opposite root, so it is going to be reflected, of the cube root of 2x. So I'm going to put in a 1, and I am also going to put in a negative 1. And then look, I'm going to put in an 8 and a negative 8 to see if we can get a perfect root here. So when we plug in a positive 1, that's just going to leave the opposite value of cube root of 2. Now look, when we plug in a negative 1, we're going to be able to take a negative out of this right here. Let me show you what this looks like. When we plug in a negative 1, that's going to be 2 times a negative 1. We're actually going to be able to take this out. Remember, negative 1 times negative 1 times negative 1 is negative 1. So we're going to be able to take this negative out. On cube roots, you can always take out a negative. It's the same as root 2 times negative 1. Remember, these are cube roots. This is the same exact property as this. I just broke up my radicals. This is going to be a negative 1. I can take this out of the root. So remember, when I take out a negative, there's already a negative here. So this turns into positive cube root of 2. Now, when I plug in an 8, we'll just plug this in right here. Negative root 2 times 8. Now remember, I can use my radical rules and I can break this up. This is perfect. 2 times 2 times 2 makes 8, so we're going to be able to take a 2 out. So if this simplifies to just a 2, then putting this stuff together is going to be negative 2, because of that, root 3 of what was already in there, which is a 2. Now again, same exact rule applies here. When I plug in a -8, just like we took out a negative, when I plug in a -8 right here, I'm going to be able to take out a -2. But remember, there's already a leading negative here, so this is going to turn into +2 cube root 2. So again, guys, these are ugly numbers, pretty much impossible to graph accurately on paper. That's why it's really important for you to just memorize the shape and to also memorize this right here. We have a negative function over here in B. See how my coefficient's negative right here? It is going to be down on the right. It's going to look like this, but it's going to flip upside down. So it goes to the origin, and you know what? I'm not even looking at trying to graph those ordered pairs, because those are impossible, guys. You just need to remember that it's going to behave like this, but it is going to be down on the right side of the origin because the coefficient is negative. So let's go ahead and talk about your homework. We're going to make it pretty easy. So let me just grab where you guys have your homework right here. So we're only going to do this front page, and I do want to make it easy. Look, we're going to clean this up. On number 34, we're going to change this. Let's change number 34 to something basic, to where it's just that. So just graph the shapes. I wish I did not even have grids on here. Just pretend they're X and Y axes. And I'm going to cross out the word graph, and I'm going to write the word sketch. So please remember, and I'll draw this down here at the bottom if you want a little cheat sheet. That way it'll help you from flipping back and forth. If you have your power functions, x to an even, x to an odd. Remember, evens always behave like parabolas. This stands for odd. Odds always behave like a cubit. It's always going to be that. So you can go through these and look at your powers here. On the flip side, remember those are powers. Then you have your radicals. I'm going to write E here for even. I'm going to go ahead and spell out the word odd because I don't want it to look like a 0. Now remember, your even is going to behave like a square root function. Your odd is going to behave like a cube root function. So draw those sketches, guys. It can be very basic. I'll go ahead and post this on the calendar for you to look at. Do not get bogged down in trying to do certain ordered pairs here. But do describe domain, range, intercepts, and end behavior, which your teacher needs to do over here. I'm going to hit pause. I'm going to fill out these attributes. That way your video won't be that much longer. Let me hit pause, put the attributes on here for domain, range, and so on, and then we'll check and make sure you guys are good to go. Go ahead and check these answers real quick and make sure that you understand them, because I'm going to ask you questions about them. Please note that as a bracket, we do include 0. Please remember these are just plain ordered pairs. Please remember you never include brackets on increasing or decreasing.